Hi everyone, welcome to geometry class. Today we're going to be in chapter 1, section 4 of our textbook, studying pairs of angles. So grab your textbook and turn to page 28 and follow along. Also, make sure to take down formulas and examples in your notes so that you can apply them later in class. So today, in this video, you'll be able to answer the following questions. How to identify adjacent angles and linear pairs, how to solve problems involving supplementary and complementary angles, and how to solve problems using vertical angles. So let's start off today by looking at a pizza. And let's imagine that you get 2 slices out of this pizza. Well, we can imagine that the slices are actually represented by angles. So we have 2 angles here, right here. Okay. So we have one angle, angle CBD, and angle DBE. And these 2 angles have a very special relationship. They're called adjacent angles, which are a pair of angles that share a vertex, in this case point B, vertex B, and share a side, in this case side BD or ray BD. And there's no overlap between the angles. They have their own interior space. So we can say that angle CBD is adjacent to angle DBE. I've also given you the other names. You can name these 2 angles. Okay. Let's compare this to a couple of other slices of pizza. Let's imagine you've pulled your 2 slices of pizza apart. And we can imagine the slices are again angles. So we have angle ABC and angle DEF. Well, since neither of these angles share a vertex and share a side, these angles are not adjacent to each other. So angle ABC is not adjacent to angle DEF. Okay, so putting these side to side, we can say that angle CBD, is adjacent to angle DBE. But by contrast, angle ABC is not adjacent to angle DEF. Okay. Let's go back to our pizza. Let's imagine that you get half of the pizza and it's been split into 2 slices, but it's half the pizza. Okay, we're going to again represent these slices as angles. And it's a special pair of angles. Again, we're going to look at this and they are 2 adjacent angles. Angle CBF and angle FBD are adjacent because they share a vertex, vertex B, and they share this side, side BF or ray BF. But they're not only adjacent angles. They form a linear pair. Remember, a pair is 2, so these 2 angles are a pair of adjacent angles whose measure add up to 180 degrees. And that's what a linear pair is. So we can say that they also have the non-common sides. So side BC or ray BC and side BD or ray BD form opposite rays. So you can see these rays are opposite rays. They share the same endpoint and they extend in exactly opposite directions to form a line. In either case, this forms a linear pair. So a linear pair is a pair of adjacent angles that adds to 180 degrees. And again, angle CBF and angle FBD form this linear pair. Okay, let's do some practice identifying adjacent angles and pairs, linear pairs. Okay, so we want to see the angles that are adjacent to angle 1. So angle 1 is right here. We want to find the angles that are adjacent to it. So the first one we've identified is angle 2. So angle 1 and 2 share this vertex and share this side. So angle 1 is adjacent to angle 2. Let's see what else is adjacent. Angle 4 is adjacent to angle 1, shares a vertex and a side. But angle 3 is not adjacent to angle 1. The reason is it shares this vertex right here, but there's no common side between the 2 angles, so they are not adjacent to each other. Okay, now let's identify some linear pairs. Angle 1 is adjacent to angle 2, but it also forms a linear pair. They are a pair of adjacent angles that add up to 180 degrees. And angle 4 and angle 1 also are a linear pair. They are adjacent angles that add up to 180 degrees. Okay, let's go back to our pizza. And let's imagine that again you get 2 slices of pizza that add up to half of the whole pizza. So these 2 angles, CBF and FBD, look familiar. They are the 2 angles we just looked at. But they also form another special pair of angles. And we're going to call these supplementary angles. They're 2 angles whose measure adds up to 180 degrees. So we can say that angle CBF is the supplement of angle FBD. That means those 2 angles are supplementary, or they add to 180 degrees. So the thing about supplementary angles is that they do not have to be adjacent angles. We just looked at adjacent angles that form linear pairs. So this would be a pair of supplementary angles since they add to 180 degrees. But you can also have supplementary angles that are not adjacent. They still add to 180 degrees, and so they would still be supplementary. All that matters is that the 2 angles add to 180 degrees. Okay, let's do a little practice using supplementary angles. So we have our pair of supplementary angles, angle GHJ, and angle KLM. And the only angle we know the measure of is angle KLM, which will hit 65 degrees. And we want to find the measure of the other angle, angle GHJ. So our first step, let's set up a relationship between the 2 angle measures. We know since they're supplementary, their measures add up to 180 degrees. So this is the first step I always want you to take in solving these types of problems. Our next step, let's go ahead and plug in the value we know for our given angle. We know that angle MLK is 65 degrees. We don't know GHJ, that's what we're trying to solve. So let's go ahead and isolate our unknown, which is this angle measure, by subtracting 65 on both sides. And we get the measure of angle GHJ is 115 degrees by just subtracting 65 on the right-hand side of the equation. Great, so let's go ahead and check our work. 115 plus 65 indeed does add up to 180 degrees, so it's important to go ahead and check our work after each of these problems. Okay, let's do another type of problem using supplementary angles. So we still have our 2 angles here, but I don't have an angle measure for either one. But I am told that the measure of angle GHJ is 2 times larger than the measure of angle MLK. So I can set up an algebraic expression representing the measure of each angle. So angle GHJ is 2x, and the measure of angle MLK is x. This makes sense because still, the measure of GHJ is 2 times larger than the measure of MLK. So that holds. Again, always our first step is setting up a relationship between the angle measures. Since they're supplementary, we know they add up to 180 degrees. Now in step 2, let's go ahead and plug in our expressions with the variable x. GHJ is 2x, and the measure of MLK is x, still equals 180 degrees. So now what we're going to do is just solve for x. So let's combine the like terms, gives us 3x equals 180, and then isolate the variable x by dividing by 3 on both sides. This gives us x equals 60. And so when we plug in for the value of each angle, we get the measure of MLK is just given by x, so that's going to be 60 degrees. And the measure of GHJ is 2x, so it will be 120 degrees. So let's go ahead and check our work again. 120 plus 60 does equal 180, so our work checks out. Okay, the last type of problem that I want to do with you all involving supplementary angles is this one. So we're given 2 angles that are supplementary, and the only thing we know is that the measure of MLK is x degrees. We don't know anything about this other angle, GHJ, and we don't know how these 2 angles are related to each other, besides that they're supplementary. So again, we're going to start with step 1, relating the measure of the angles together. The sum equals 180 degrees. So the measure of GHJ plus the measure of MLK equals 180 degrees. Well, let's go ahead and plug in what we know. We know that MLK equals x degrees, but we don't know GHJ. So what we're going to do in this type of problem is not get an actual value for either of the angle measures. We're going to leave it as an expression. So I'll tell you what that looks like. We'll see that in just a second. So we want to solve for this angle measure, so I'm going to get this all by itself on one side of the equation. And to do that, I'm going to move the x over to the right-hand side of the equation by subtracting x on both sides. So that leaves me with measure of GHJ all by itself equals 180 minus x, which is an algebraic expression, but that is what we want for the measure of GHJ. Okay, let's go ahead and check our work. If the measure of GHJ equals 180 minus x and the measure of MLK equals x, I can make sure that the sum equals 180 by adding them together. So the x's cancel out, and I still am left with 180 degrees. So our work cancels, our work checks out. So even though we don't get a number, an actual number, we just have expressions, that's okay for this problem. Okay. Let's go back to our pizza. So you still get 2 slices of pizza, but this time your slices add up to a smaller amount. If we represent these slices as angles again, we see that the angles add up to a special amount, namely 90 degrees. We can see this by the 90-degree symbol, the perpendicular symbol here. So when we have 2 angles that add up to 90, we call them complementary angles. So complementary angles are 2 angles whose measure adds up to 90 degrees. Okay. So just like supplementary angles, complementary angles, which add up to 90 degrees, can either be adjacent, they share a vertex and a side, or they can be not adjacent. They're separate, totally separate angles. But still, the measures add up to 90 degrees. So in these 2 angles, we can say that that angle FGH is the complement of angle JKL. Okay, let's do some practice using complementary angles. We have our 2 angles here, and we know that the measure of FGH is 35 degrees, but we don't know what the measure of JKL is. So, just like we did with our supplementary angles, we want to have a relationship between the 2 angle measures before we do anything else. So, since these 2 angles are complementary, we know that their measures add up to 90 degrees. Okay, step 2, let's go ahead and plug in what we know. We know that the measure of FGH is 35. We don't know this measure, and we know they add up to 90. So to isolate measure of JKL, I'm going to subtract 35 on both sides. And that leaves me with the measure of JKL is 55 degrees. Let's go ahead and check our work. When we add these up, equals 90 degrees. Great, our work checks out. Okay, let's do another example using complementary angles. Again, we have 2 angles that are complementary. We don't know either angle measure, but we are told that the measure of JKL is 30 degrees larger than the measure of FGH. So let's go ahead and make an algebraic expression for each angle measure. We can say that the measure of FGH is x, and the measure of JKL is x plus 30. And that still makes sense because the measure of JKL is still 30 degrees larger than the measure of FGH. So those expressions check out. So again, step 1 in this problem is adding the 2 angles together, writing the angle names out, it's very important, and then equaling the sum to 90 degrees. So let's plug in the expressions for each angle. We have x plus 30 equals 90. Then let's combine like terms on each side. We have 2x plus 30 equals 90. Then let's go ahead and combine like terms on either side of the equation by subtracting 30 on both sides to combine the numbers on the right-hand side. When we simplify, we get 2x equals 60. Then let's isolate the variable x by dividing by 2 on both sides. So x equals 30. But we want to solve for the measure of each angle. So let's plug x back in. So we get the measure of FGH is 30, because it is just x, and the measure of JKL is 60. Well, again, when we add up these 2 angles, they equal 90. So our work checks out. One last example using complementary angles. We have our 2 complementary angles. All we know about one of the measures, measure FGH, equals x minus 20 degrees. This is an algebraic expression. And we don't know anything else about this angle and how these angle measures are related besides that they are complementary. So again, our first step is adding the two angle measures together, setting them equal to 90. Please always write this as the first step. Then let's plug in what we know. We know the measure of FGH is x minus 20, and the measure of JKL we're trying to solve. Both the sums equals 90 degrees. So we're going to, again, solve for an expression for the measure of JKL, just like we did in our last example for supplementary angles. So let's see what that looks like. I'm going to combine like terms on both sides, so I'll add 20 to both sides. That'll leave me with x plus the measure of JKL equals 110 degrees. But I want to solve for the expression for the measure of JKL. So I'm going to move this x over to the right-hand side by subtracting on both sides. And the expression that I get is the measure of JKL equals 110 minus x. Okay, let's see if our work checks out. If I add these two angles together, I should get 90 degrees. So when I do that, the x's cancel out. 110 minus 20 equals 90 degrees. So these angles are complementary, given by each of these expressions. Okay, the last thing we'll talk about today. Let's imagine you have your pizza again. You just took it out of the oven and you're about to serve it. And you've cut your pizza all the way across in two different ways. This way and that way. Well, we can represent those cuts as lines that intersect right here. So these two intersecting lines form a special type of angle pair. Vertical angles are two non-adjacent angles formed by two intersecting lines. So what does that mean? Essentially, they're going to be two angles that are across from each other, across from the intersection. So angle 1 and angle 3 are across from the intersection from each other. So they are vertical angles. One way I like to look at this is that two vertical angles form a right side up and an upside down V, form a pair of V's with each other for vertical. Okay, so angle 1 and angle 3 are vertical. Also, angle 2 and angle 4 are vertical. They're across from the intersection from each other. They form a pair of V's. A special feature about vertical angles is that they are congruent to each other. So angle 1 and 3 are vertical, and so they are congruent. That means the measures of each of their angles are equal. So the same thing goes for angle 2 and 4. Angle 2 is congruent to angle 4, and the measure of angle 2 is equal to the measure of angle 4. So let's do a little practice involving vertical angles. So the measure of angle 1, we're told, is 80 degrees, and we want to find the measure of angle 3. Well, we know that they are vertical angles, so I can set up the relationship for our first step that the measure of angle 1 equals the measure of angle 3, since they are vertical and they're congruent. Remember, these arc marks tell us that the angles are congruent, and we can say that they are congruent because they are vertical angles. So our next step is to plug in the value for the angle measure we know, which is angle 1, 80 degrees, which equals the measure of angle 3. So the measure of angle 3 equals 80 degrees. Okay, let's do one last example using vertical angles. We're given an expression for each angle measure. Angle measure 2 equals x plus 80, and then measure of angle 4 equals 2x plus 60. So we know that they are vertical, so we can set the measures of each of their angles equal to each other. So our next step is to set the expressions, plug the expressions in, and set them equal to each other, just following step 1, plugging in the expressions from step 1. So let's go ahead and set out to collect like terms. To do that, let's go ahead and subtract x on both sides. When we simplify, we get 80 equals x plus 60. The x's cancel here. 2 minus x is just 1x. So then let's go ahead and combine the numbers on one side of the equation, on the opposite side as the x. So we're going to subtract 60 on both sides, which that gives us 20 equals x. So let's go ahead and plug in x equals 20 to both expressions. So the measure of angle 2 was given by x plus 20, so 20 plus 80 is 100 degrees. And the measure of angle 40 when we plug 20 in equals 100 degrees. So our work checks out. Both angles equal 100 degrees. Okay, one last thing. When we formed vertical angles, they were formed by intersecting lines. In our last two examples, we found that the measure of angle 1 and angle 3 were both 80 degrees, and the measure of angle 2 and 4 were both 100 degrees, which makes sense since they were vertical and then congruent to each other. But we also have a special relationship between these two angles. They are supplementary, they add to 180 degrees, and they also form a linear pair. They are adjacent angles that add to 180 degrees. The same relationship holds for angle 3 and 4. We can flip this around and say the same things for angles 1 and 4 and angles 3 and 2. Okay. So in review, you've learned how to identify adjacent angles and linear pairs, here and here. You've learned how to solve problems using supplementary angles. You've learned how to solve problems using complementary angles. And you've finally learned how to solve problems using vertical angles. Great job today, guys.